As the global volume of electronic waste continues to grow, printed circuit boards have become one of the most valuable and challenging materials to recycle. PCBs contain a high concentration of copper and precious metals, but they are also complex composite materials, combining metals, resins, fiberglass, and electronic components tightly bonded together. When PCBs are processed improperly, metals remain trapped in resin, recovery efficiency drops, and downstream costs increase significantly. To solve this problem, our PCB recycling solution is designed as a two-stage system, combining a PCB thermal dismantling machine with a PCB motherboard crushing and separation line. This integrated approach allows us to first dismantle, then liberate, and finally separate materials with high efficiency and stability. The recycling process begins with the PCB thermal dismantling machine, which is specifically designed for PCBs with electronic components. Instead of directly shredding loaded boards, which often leads to metal entanglement and poor liberation, this system uses controlled thermal treatment to weaken the solder connections. When the solder reaches its melting point, electronic components such as ICs, connectors, capacitors, and metal inserts are released from the PCB surface without mechanical damage. After thermal dismantling, the material is naturally divided into two valuable streams. The first stream consists of separated electronic components, where metals are highly concentrated and easier to handle for further refining or specialized recycling. The second stream is the clean PCB motherboard, now free from components and much more suitable for efficient physical processing. This step significantly reduces the burden on the crushing system and improves the overall recovery rate of valuable metals. After thermal dismantling, the PCB motherboards enter the crushing and separation line, where the main objective is complete material liberation. The first stage is a dual-shaft shredder, which performs coarse shredding. This step opens up the PCB structure, reduces the material to a manageable size, and ensures stable and continuous feeding for downstream equipment. The shredded material is then processed by a hammer crusher. At this stage, the focus is on breaking solder bonds, releasing copper foil, and separating metals from the resin and fiberglass layers. Compared with simple shredding, hammer crushing provides higher impact energy, which is critical for effective liberation. Following the hammer crusher, the material enters a milling system for fine crushing. The grinding process further reduces particle size and improves the degree of liberation between metal and non-metal materials. This step is especially important for multi-layer PCBs, where copper foil is tightly bonded within the board structure. After milling, the material is classified by a circular vibrating screen. Particles that meet the required size range proceed to the separation stages, while oversized particles are automatically returned to the milling system for reprocessing. This closed-loop screening design ensures consistent particle size and stable separation performance. The qualified material then enters the air separation system. Based on density differences, heavy metal particles such as copper and solder are separated from lighter resin and fiberglass powders. This stage is the core of copper recovery, where the majority of metal is efficiently concentrated. To further improve recovery efficiency and product purity, the remaining material undergoes electrostatic separation. This final separation stage removes residual metal particles from the non-metal fraction, minimizing metal loss and significantly reducing copper content in the resin and fiberglass output. Through this integrated process, the final products include high-purity copper and copper tin mixed powder, concentrated electronic components from the thermal dismantling stage, and low metal content resin and fiberglass powder. These outputs are highly favored by smelters and downstream processors due to their high liberation degree and stable quality. By combining PCB thermal dismantling with a complete crushing and separation line, this recycling solution provides a reliable, scalable, and environmentally responsible approach for processing PCBs with components. It maximizes metal recovery, improves product value, and supports the sustainable development of electronic waste recycling.